Welcome to another lesson. Today we're going back to basics. We will be discussing the topic of linear equations. Alright, but before we get there, a few things we need to discuss first. And you hopefully have seen this from your high school days in algebra. These crosshairs, right, we call this the x-axis, the horizontal. The vertical we call the y-axis. All right, sometimes referred to as a Cartesian plane, named after the French mathematician and philosopher René Descartes. On here, right, we can mark off units, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You don't have to stop at 10. In theory, it continues to infinity, but unfortunately, my chalkboard is not that large. Likewise in the y, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And even into the negative. So this would be the positive x. This would be the negative x-axis.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Positive y-axis is up. Negative y-axis is down.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
You may hear the center referred to as the origin. And the coordinates there are 0, 0. So when we talk about coordinate pairs, all right, coordinate pairs, that's going to be a y coordinate and an x coordinate. So let's say P for a point is going to equal some, say, I don't know, P sub n is equal to some x sub n and y sub n. So we list the x coordinate first. Example, P1 is equal to -1, 1. All right, so the x coordinate is first. That's a -1, so starting from the origin, I go to -1 in the x, then a +1 in the y. I'm gonna put a dot right there. If I do P2, all right, let's say that's 5, 4. All right. So 5, we start with the x, right? X goes first. +5, 1, 2, 3, 4, 5. And then +4 in the y, 1, 2, 3, 4. So that's about here. All right, point 1, point 2. Now, we have 2 points. This is going to set us up for linear equations. I can draw a line to connect the 2 points. So using a straight edge, and that line even extends beyond the points. Okay, so I can use arrows to indicate that it extends in both directions. Okay, so before we forget, we said this was 5, 4. This was -1, 1. We have a line. To describe any line, we need 2 pieces of information. So that could either be 2 points, point 1 and point 2, or it could be 1 point and the slope. Now, what is the slope, you might ask? Well, of course I drew this here, so I'll have to move it over, -1, 1. The slope, you can think of as this triangle. We'll line it up there. Okay, you can think of it as a triangle. So we call this part the This part is the rise, okay? Rise. The horizontal part we call the run. Okay, so slope is equal to rise over run. Okay, another way to express it is, well, what's the rise? If I said this is 0.2 and this is 0.1, well, we're taking the y-coordinate, we're taking y2 minus y1, and then the run is similarly the x-coordinate, x2 minus x1. You might also see this referred to as delta y over delta x. So this symbol that looks like a triangle, delta, means change. Delta y over delta x. Okay, so these all are ways to express slope. I'm just giving you different ways you might encounter it if you're reading a textbook on the subject. So, in this case, slope. And while we're talking about notation, slope is often symbolized by the letter m. Okay, m is slope. So in our example, m is equal to, well, what did I say? y2 minus y1 over x2 minus x1. All right, so what is y2? Well, this is the x-coordinate, that's the y, so I'm going to go with 4. Okay, x-coordinate, y-coordinate, so I'm going to go with the positive 1. Okay, now the run is x2 minus x1. So x-coordinate is 5. That's x2. x1 comes from 0.1. That's negative 1. So minus a negative 1. Okay, 4 minus 1 is 3. 5, okay, minus a negative is a positive. So 5 plus 1 is 6. Okay, notice I can reduce this fraction to 1 over 2. So my slope is going to be 1/2 in this case. We've discussed what the slope is. Now let's talk about intercepts. This point here, where we cross the y-axis, is called the Y-intercept. Okay, so there's a couple ways we can find that. I just calculated the slope is 1/2. So looking at the graph, starting at 1, going up 1 over 2, well, that's splitting the difference. So I can see that's halfway between 1 and 2. I can see that, although I wouldn't encourage that method too much, especially for beginners, because what if this were a slightly shallower slope? All right, and you saw, oh, it's somewhere between 1 and 2. Well, it's easy to assume that it's 1.5, but what if it's 1.3 or 1.8? For that reason, I would discourage it. There's a way we can calculate and then use the graph to check our answer. To get there, we're going to have to, we can discuss 3 different ways, 3 different forms a linear equation can be expressed. Let's just recap this, then we'll get into the different forms in the next lesson. We have our Cartesian plane, right, an x and y axis. I forgot to mention, sometimes we refer to these as quadrants. So this would be quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay, you might see the quadrant notation at some point. Cartesian plane, we discussed coordinate pairs. All right, and saw an example. Point 1, -1, 1. So -1 in the x, +1 in the y. Put a point. Point 2 is 5, 4, so we go over +5 on the x, the horizontal, and up 4 on the y, the vertical axis. Put a point. We can connect the two dots. From that, we can calculate the slope, all right, using rise over run. y2 minus y1 over x2 minus x1. In this case, we subtracted 4 minus 1 is 3. 5 minus a -1 is 6. 3 over 6 reduces to 1/2. I'll leave it there. Let's pick up next time with some different forms that we can express this in. I'll see you then. Thanks for watching.